Hello everyone, this is Dr. Dave with Physics 150 at K College. I have a video here that I wanted to upload because there were a lot of people during office hours today that clearly were having a difficult time breaking vectors into components and weren't entirely certain how to do that or even what it would mean after they did it. I realized that this, for most of you, is going to come after problem number 9 was due. Don't worry. Vectors are going to be used all throughout Physics 150 and Physics 152, so what we're going to talk about today will be useful going on later. If you find this little video helpful, please do let me know so that I can try to make some more of them for you. There is another video that I uploaded to YouTube a little while ago. However, it came to my attention that there is no audio. I'm not entirely certain that that is a useful video to watch without the audio, but in it, there are many examples of me breaking vectors into components that you might find useful. So I'm going to try to do a quick sped up version of that and just kind of give you the meat and potatoes right now. So let's imagine I have these two scenarios, case 1 and case 2. So the question I have for you is which one is speeding up, which one is slowing down? Hopefully by this point in the course this is a really clear answer to you, but just in case, this case is speeding up. Why? Well, because the acceleration is in the same direction of the velocity. And remember that acceleration is just the derivative of velocity with respect to time. And because I know not everybody knows really what a derivative means, it is the change of velocity with respect to time. So if the velocity is changing in this direction, that means it's going faster. So by process of elimination, this is the case in which I'm slowing down. Why? Well, the velocity is in this direction, but the change is in that direction. So therefore, the object is slowing down. Now, in one-dimensional motion, which both of these cases are, this is a really easy question. Is it speeding up or is it slowing down? Now we have to ask what happens if the acceleration is not in the direction of the velocity, but looks something like this. So that's a little bit more complicated. In the first case, what we would describe is we would say this acceleration is tangential. Why do we say it's tangential? Well, we imagine that this velocity is this velocity is either in a straight line, which tangential doesn't necessarily help us too much, but if that velocity instead was part of a curved motion, we see that this velocity is tangent to that curve. So the physics we've been looking at in the first 2 weeks, everything was really tangential. And so now we're looking at a different scenario. So now we're going to ask ourselves a question, how does this acceleration affect this velocity? Well, what we're going to do is break it into components. Components of the acceleration that are in the same direction of velocity, which we call parallel. We also call it tangential, again, because we're thinking of a curve. And so what we're going to do is draw a triangle. The first thing to always remember if you have a hard time visualizing how this is supposed to work is your original vector will always be the hypotenuse of your triangle. So if you draw your triangle and this is just a leg, you have made an error. Go back and do it again. So we're going to draw it as a triangle, and we're going to draw it as the sum of two vectors. That is, here is my triangle. I have a part of it that's tangential and a part of it that's perpendicular. So what does that look like? Well, so here we go. I'm going to draw this piece here and this piece here. And you might ask, like, well, how long should each of the legs be? There really is only one answer, and the answer is whatever makes that triangle. Okay, so this is going to be the A tangential or the A parallel, and this is going to be the A perpendicular. And let's remind ourselves that there's always supposed to be a right angle here. Now, some people might have done this before, but they might draw a different triangle. They might draw this triangle here and that triangle here, calling this the A perpendicular and this the A tangential. Both of those answers are completely fine. They give you the same answer. Now, another thing that some students find confusing is they say, well, how do I know to put the arrow here and not instead there? Well, in that case, I simply have to make you go back to vector addition. That is, when I add this vector and this vector, I will get that vector. If I were to have instead added this vector and this vector, I would have gotten the opposite vector. This is outlined in Chapter 3 when vectors are introduced. If you're having a hard time, please go back to that. All right, so now that I've split this into A tangential or A parallel components and A perpendicular, or what's also known as A centripetal components, what does it mean? Well, what this means is that this object with this velocity is changing its velocity in the direction of the motion, and it's changing its direction that it was moving. So this acceleration says it's speeding up and turning. So a moment later, you might imagine the velocity vector will look something like that. All right, what about the fourth case? What does this acceleration mean to the motion of this velocity? Well, the first thing you might try to do is like draw a triangle like this or something. But that's not treating this as the hypotenuse, and it's not creating a right angle. Again, the reason we want right angles is because we want to have independent components, so we want to split the acceleration into parts that are parallel and perpendicular to the velocity. So if I can't draw that triangle, what do? Well, we're actually still doing the same thing we did before, only now we're pretending that the velocity extended the other way. And we're going to draw it like this. Now, if that's confusing to you, you will get more used to it over time. And that's kind of the promise I can make to you. So there's that. And now I'm going to draw this, again, keeping this as the hypotenuse. I'm creating my right angle here. This is the component of the acceleration that was parallel. So I'm going to call that A tangential again. And this is the part that's perpendicular, so I'll call it A centripetal or A perpendicular. So now the question might be, well, which way do the arrows go? Well, let me make this a little bit bolder. The acceleration is heading in this direction. So whatever ways I put arrows here have to add up to give me this one. So the only way to really do that is to add this vector and that vector. If you don't believe me, try drawing different ones, and if you add the vectors correctly, you'll not find another solution. So here we go. This is A tangential, and this is A centripetal. So now, let's draw it a little bit differently. Let's draw the A centripetal right here. Now, why am I doing that? There's no difference. I'm just trying to separate the two vectors to see them. So what does this mean? Well, the acceleration pointing this way says that the velocity is changing in that direction. That means it's slowing down. And it means the velocity is changing this way, which means it's turning. So at a later time, you might expect the velocity to look something like that, or maybe even less, to be slower. Thank you for watching the video. If you did find it helpful, please do let me know. I hope it wasn't too brief. It's Friday night, about 7 o'clock. You probably won't see this before you turn in your problem set. However, decomposing vectors really will be a skill all throughout physics. Thank you.